This is question number problem 14-18. Young Corporation expects an EBIT of $30,800 every year forever. So this is a perpetuity. The company currently has no debt and its cost of equity is 14%. The corporate tax rate is 35%. Part A, what is current value of the company? So currently the firm doesn't have any debt. So part A is basically asking what is the unlevered firm value. Notice here the rounding requirement. Do not round intermediate calculations and round your final answer to 2 decimal places. So as the first step, let's put all the information down. So currently it's unlevered and EBIT is provided. This is $30,800 forever. Right? This is perpetuity, and cost of equity is 14%. Right, so that's RE, or maybe to be consistent, let me just use RS. S stands for stock, and tax rate. Right? Tax rate is 35%. So what is the current value? So since this is a perpetuity, and we just need to use the present value of the perpetuity formula. And the implicit assumption here is that shareholders will get all the after-tax EBIT. So basically, it implicitly assumes that the firm has a 100% payout policy. So we can use that. So after-tax EBIT times 1 minus tax rate. So that's the after-tax EBIT. That equals just use the reference, cell reference, right? So and make this to be a number rather than percent. So this is after tax sort of cash flow to the shareholders, and we also know the shareholders cost of equity. And since this is a perpetuity, so we can use the present value of the perpetuity formula, which is the annual cash flow divided by the discount rate. So the discount rate here should be the cost of equity. So hence VU, which is the unlevered firm value, that should equal to after tax EBIT divided by the cost of equity. So that basically will be the answer for our first part of the question. So where is that? So it's right here. So the current value is 143,000. Right, 143,000. Going back to that. Yes. And so continue B-1. Suppose the company can borrow at 9%. Yeah, so also going back to part A, it's round the answer to 2 decimal places. But here, since it's an integer, so it doesn't matter actually. So go on to B1. Suppose the company can borrow at 9%. So that means just write down that information, right? So it's RB, which is bond, which is cost of debt, is 9%. And what will the value of the firm be if the company takes on debt equal to 50% of its unlevered value? So first, from this sentence, we can tell the B, the total size of the debt, because we know the unlevered firm value, which is 143,000, and this is 50%, right? 50%. So it's going to be unlevered firm value multiplied by 50%. So this gives me the total value of the debt. total size of the debt. Right, so that's and then we can simply use the M&M Proposition I with taxes to figure out the value of the firm with some debt. If you go back to the next slides, so let's see. So that so the Proposition I under taxes basically says VL, which is the levered firm value, equals VU, which is unlevered firm value, plus tax rate multiplied by B. So all the right-hand side information now is available, right? So we know VU and tax rate, we just figure out B. So we can just use this formula to figure out levered firm value. So VL simply equal to VU plus B times the tax rate. So that gives me 168. Just copy that number back if possible. Copy the number back. Yeah, so I think that's possible. So that's basically the answer for B-1. B-2, suppose the company can borrow at 9%, still same setup. What will the value of the firm be if the company takes on debt equal to 100% of its unlevered value? So this is basically changing the fraction, right? The percentage of the total size of the debt as a percent of the unlevered firm value. So that also actually teaches us a lesson, right? So what's the lesson? Lesson is not to hard code the data. So fraction of debt to, let me put another row as a fraction of the debt to unlevered firm value. So make this as a separate row. And for the first part, B-1, it's 50%. So now I just need to use the cell reference, right? Rather than hard coding the data, I just need to use the cell reference. For part B-1, obviously this won't change the answer, but now notice how convenient we can get the answer for part B-2 is simply to change this fraction, and everything will adjust automatically. So now I just need to copy the new levered firm value back to this blank, and this will give me the answer immediately. So part C-1, what will the value of the firm be if the company takes on debt equal to 50% of its levered value? So now the key is that it's a levered value. But levered value actually is not known. We need to figure out this levered value. And now debt will be 50% of the levered value. So obviously we have this sectionality problem, right? In order to know levered value, we need to know the amount of the debt. But in order to know the amount of debt, we also need to know the levered value. And one way we can solve this problem is to use the equation, right? So how can we use the equation? We can just put this as something to write on the note. So let me use OneNote for Windows. Just have some. This is like my scratch paper. So what I'm trying to do here is to use the Modigliani and Wiener M&M Proposition II, Proposition I. Sorry. So I don't know what's wrong there. Seems that some unexpected. Okay, so let me go back to my digital pen. So basically what I want to do is to use this equation, VL equals VU plus TC times B. So now it's telling us that B equals VL times 50%. So we can just plug in this, right? The right hand side now will become VU plus TC times VL times 50%. So now both the left-hand side and the right-hand side has the term involving VL. And now we need to know VL, right? We need to figure out VL. So, and this is just the VL is the only unknown here. VU is calculated TC is provided. So VL is the only unknown here. So obviously this is a one unknown equation, and we can solve out this unknown VL. How? We can just move this term TC times VL to times 50% to the other side, and so this equation will become VL minus, right? When we move the sides, when we switch sides, we have to change the sign on the term. So this will become VU. Now we can combine the terms involving VL, right? The VL on the term, the second term here involving VL, the coefficient on VL is TC times 50%. And the first term here is 1. So it's 1 minus TC times 50%. And parentheses VL equals VU. So now I can just solve out this VL. VL will be VU divided by 1 minus TC times 50%. Again, for this part of the problem, the fraction here is 50%, but just to learn some lesson from part B, I don't want to hard code the data, because for part C-2, right, if you read the C-2, you see that it's asking for the value of the firm if the company takes on debt equal to 100% of its lever value. Right, so in this case, you can the only thing that changes compared to C-1 is this fraction of the debt relative to lever value. So that's why here I can rather put the fraction rather to hard code that fraction into the formula. I will put this as a separate variable, separate row to lever value. So for C-1, this fraction here is 50%, and based on our calculation, right, VL, just going back to my notes, so VL equals VU divided by 1 minus TC times that fraction. So let me just put the to F to stand for that fraction, right? So TC times 1 minus TC times that fraction. So and to be absolutely clear, so this is now AF, little f, okay? So now I can just plug in the formula to get VL, right? Because I know the VU and I know the TC, and I also know the fraction. Right? So this will immediately give me the final answer. So now I can just copy, sorry, I'll constantly make. So this is my final answer to part C-1. Again, because we have followed sort of the best practice in never hard coding the data in Excel. So what we can do in order to get the answer to the final part of this question is simply to change this ratio. Change the fraction here, so that answer will automatically adjust. Right, so now I can just check my work and save the information. Okay, I don't need this. So just double check. You can see I got all parts correct. So that is how we can solve out this equation. This problem.